Alright, today's lecture is on soldering and desoldering. What is that? That's where we're actually going to place components onto a board. Alright, and we're using solder, which is a solid, actually we heat up, liquefies, and then resolidifies in a matter of seconds. So that we can permanently attach components to a board. That way we have great connections and everything works good. The component stays there and we're making all the electrical connections. Alright, so we're going to cover what the tools we need, the process of soldering. I'm going to do an example in class in front of you of soldering so you can see how it actually happens. There's some videos at the end of the lecture I want you to click on and watch as well. It's going to take us a couple different things that we're going to solder before we get good at it. Some of you guys are going to ruin your board or heat it up too much, or some of you guys are going to be just fine, and it's okay. It's a learning process. So we have 2 or 3, maybe 4 different projects that we're going to solder, and then the rest of mechatronics you'll kind of solder as we need to on different projects. But essentially we're just welding electrical components. Okay? So taking a look at some of the different tools that we need to solder. Alright, I don't have a bunch of vices. I have some helping hands, and we'll kind of go over that in class as well. But it's being able to actually hold your component or your board. You place your board in the vise, and then you're able to actually access all of your components and put them in there and solder much better and safer. We will always wear safety glasses when soldering. That's just for multiple reasons. You don't want to accidentally hit you in the eye with a solder iron. Solder can splash. We use a solder sucker in picture 3 that can shoot solder. Just working together. If you're clipping wires when you're soldering, they're going to fly all over. And we cover a lot of this stuff in the safety portion as well. So just different tools that we're going to use. We need to know the difference between picture 5 and picture 6. So picture 5, those are diagonal cutters, versus 6, which are needle nose. Alright, the diagonal cutters we're going to use to get real close to the board and cut the legs of the components off. Needle nose will help us bend the wires and pull them through. You have to do that with resistors, things that have long legs on them. We're going to use picture 3 quite a bit, solder sucker. So if you do some bad solder joints or some solder bridges, or we got to clean stuff up, those work really good at getting it. I like them better than what picture 8 is, the solder wick. I'm not a big fan of solder wick. I like the solder suckers better. But 7, okay, that's solder. That's just a little bit of solder, and it's a little tube for you to hold. I'm just going to cut pieces of solder off for you. I got bigger spools of solder that we're going to pull from. Solder is the actual material that bonds the component to the board when we're doing that. 9 is very important, having a damp sponge. We always need to make sure our tip on our solder iron is clean. Alright, and that helps us actually solder much better as well. And 10 is the soldering iron, and there's a stand for it as well. So solder irons, they can come in different shapes. This is probably the most common solder iron look. This is the ones we're going to use in class. They typically are anywhere from 25 to 30 watts in power, but that may not mean anything to you now. But what you need to understand and be very, 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 very careful with and cautious with, okay, these are at 400 degrees Celsius. That equates to about 750 Fahrenheit. That tip is very hot. So when we are soldering, safety is the utmost key. You have to pay attention to where that tip is at all times. Even if it's in its soldering stand sitting in the holster, you have to make sure that the electrical cord for the solder iron is nowhere near there, because it will melt it in an instant. Happens every year. Alright, so we got to be cautious, be cognitive, be alert. Soldering isn't something that we're having discussions with. Okay, we're quiet, we're focused. This is very dangerous. Okay, also don't use this to carve into the tables, the desks, any of those sort of things. It is literally only to melt solder, and that's the only purpose that we will be using it for in class. Alright, don't be scared. It's very easy. Alright, it's intimidating because that tip is very hot. You will all probably touch it at one point or another. I have burned myself as well. Okay, we can never be too cautious with that. Alright, what is solder itself? It's a metal alloy. Alloy means that we're combining different metals to make something. So in this case, it's an alloy of tin and lead. Alright, metals that we can heat up quickly that don't need, it's not like steel and iron and all that sort of thing where we have to be at a really, really, really high temperature. I mean, it melts at 361 Fahrenheit, but we're getting up to 700 Fahrenheit on these solder irons. So, I mean, it's not a really high temperature, but it's a high temperature to you and I, but not for that. So that's why we use this metal alloy solder. Alright, it's a 60-40 split because it's 63% tin and 37% lead. So since it is lead, alright, what we have does have a little bit of lead in it. We got to make sure that we wash our hands very good after we are done soldering. Okay, it's not going to contaminate you or anything like that, but we've got to wash our hands so if you eat afterwards or we go to lunch afterwards, you're not having lead on your hands. So we will always make sure that at the end of class we will always wash our hands with that. Okay, important thing that you need to do every single time that you start soldering is tinning the tip of your solder iron. Okay, what is tinning the tip? Okay, we're going to take a thin layer of solder and wrap it around the tip. Now we're not going to wrap it per se with our hands or things like that, but we can look at the two different pictures here. There's an untinned tip and a tinned tip. Okay, the untinned tip, alright, doesn't have any solder on it yet. Okay, we do this so that we have better transfer of heat to our workpiece. So every single time when you start soldering for the day, you're going to plug in your solder iron and you're going to get your sponge wet and do that. You're going to tin your tip first. Okay, people that don't tin their tip, we end up having really bad tips that don't work. It's really bad for the solder iron. So please always make sure that we are tinning the tip. And how do we do that? I'm going to demonstrate it in class too. These pictures don't necessarily show it 100%, but you're going to apply a little bit of solder to the edge of the iron, and then you're going to roll the iron in the sponge, the damp sponge. Alright, that rolling it is so that you can spread the solder around while it's in a liquefied form. Alright, and then once you lift the iron tip up, alright, it's going to be stuck to the tip, and you have a very good sharp. You want a very good sharp tip. Okay, when you're soldering. If you have a dull tip or it only heats up on one side, makes it very, very challenging for you to solder. Alright, so how are we going to solder? Like I said, once again, I'm going to show you in class how to do it in person. If you're not in class and in person, there's going to be videos at the end of the lecture. You can click on some links and watch people solder. Or when you come in, if you missed class, I can show you at another time, or I can have a classmate show you. Okay, but essentially, alright, you're gonna have your board. Okay, notice on the board the little circle pieces. That's what you're gonna be soldering to. They're pads, alright, but they're conductive. Alright, so that's what you're gonna solder to. So what you're gonna do is you're gonna put like your resistor or your LED through. Alright, that's the wire that's sticking up in the picture. Alright, and then you're going to bring your solder iron over and touch the wire. It's going to heat the wire up. The wire does not melt. Alright, so the wire on your resistor does not melt. Your LED doesn't melt. The only thing that's going to melt is the solder. And you bring the solder in with your other hand and you place it against that wire that's already heated up. And as you can see in picture number 2, the solder starts to liquefy and melt. It only takes a second. Like literally, you're just down there and it's like a drop of solder real quick, and it drops onto the pad. So you can see in picture 3, now there's no longer a hole. You can no longer see the pad. The pad is completely covered in solder, and the component, alright, is not going to move now. The wire itself will move, and then we're going to clip that. But the component's not going to move now. It's fully soldered in to the board. One thing you got to make sure when you solder, alright, that you've pulled your resistors all the way through so they're flat, or you have your LED flush. And I'll make sure I show you guys that in class when we're doing our solder. So what does a good solder joint look like? This is a good solder joint. Okay, the pad's completely covered. It's a concave, bright shine. Okay, and there's not burn marks around the board or anything like that. It's very clean. It's a nice little, like, Hershey's Kiss, I guess would be the good analogy for this one. Make it a Hershey's Kiss, all of these, if you can. Alright, what are some bad solder connections look like? Alright, the one on the left, a couple different issues there. Too much solder, alright, and you had the solder iron too close to the board for too long. Because notice how it's kind of like that dark and shiny green. Well, you started melting the insulation layer there. Because all the little metal strips, they're under a layer of insulation. The only thing that's really exposed is the pad that you're putting the solder on. Alright, if we look at the picture on the right, not enough solder. I would say the majority of you guys are going to have this problem when we are doing the IC chips. They're a little bit harder because the pins are closer together. But all you got to do is put more solder on, and it's fine. I'd rather you have a little bit more than less. The problem with having too much solder, one, you can see that it impacts the board. Two, we may not get good connections then, because there's just a big bubble, and you might not actually be on the pad then. So you got to be careful about those sort of things. The one on the left here, this is a cold solder joint. Alright, why is it? Well, let's take a look. Notice how there's different deformations in the solder. There's some cracks, there's some holes and things like that. It's not going to give us a good solid connection. So that's what a cold solder joint is. And then, not enough solder in the other one. Okay, not enough solder means that it is not soldered. It looks like it's soldered, right? There's a whole bunch of stuff on the pad and on the outside. But if you can see the wire component in the middle, alright, it's still protruding through a hole. You don't want to see a hole there. That hole needs to be filled. So you would need to put another bubble of solder on top of that. Make it a nice Hershey Kiss. The picture on the left here, it's a solder bridge. That means that you accidentally connected those two components and they're not supposed to be connected. Once again, when we're doing the integrated chips, you guys are going to probably have this issue. This is not a problem. We can correct it. Alright, we can reheat this, and when we reheat it, you'll see the solder liquefy, and we use the solder sucker, and it sucks it right up. So it's a problem if you leave it that way, but it's not a hard problem to fix. But we got to avoid solder bridges, connecting components that aren't supposed to be connected. Alright, what we can have happen is what's on the right, the lifted trace pad. Okay, once this happens, we cannot fix this for the most part. It jacks up all the different connections and things. We might be able to glue it back down and solder, but we'll see. But that comes from keeping too much heat. That comes from scraping it with a tip, and just way too much soldering activity going on in one place. Soldering should be getting in, getting out, and you're done. Okay? It will take practice. Please don't expect to know how to solder something after you put in the first one or two pieces. But by the end of our second piece, you're going to be much more comfortable with what you're doing. Alright, so here's a picture of some just different bad solder positions, or solder connections, sorry. If we look at this, we got the cold joint. There's not enough, so I'm going to work left to right here. Left hand side, just not enough solder on there, and you can see that it's not nicely sitting down on the pad. It's kind of up, which means I might be able to slide that component in and out. Wouldn't be good. Same with the cold joint. We already saw that. Insufficient wetting, right? We have solder all over the wire, but it didn't get on the pad, so there's no connection. Same with the next one, insufficient wetting. Now the other joint there, that one looks okay. Then we have the big dome, too much solder. Most likely that connection will work, but it's probably not going to be good connections. Alright, because since it's a big dome, it might be loose underneath. Okay, the second one from the right there, that's okay. That's our perfect Hershey Kiss. Alright, so we don't want... You can see the difference between the too much solder ones and the okay ones. We're looking more for Hershey Kisses instead of domes or bubbles or BBs or whatever you want to go with there. But you'll get the practice of it. We can fix every single one of these by reheating it and using the solder sucker to remove the solder and then resoldering it. So it's okay if we make mistakes. We can correct them. Alright, and I keep saying desolder and that sort of thing. The videos at the end I'll show you how at the end of class, but you can see in picture 1, what are you doing there? You're bringing the soldering iron in on one side, you're heating up the solder and liquefying it. Once you see it turn to liquid, you hit the button on the solder sucker and it pulls it right up and you're able to pull your component out. Please remember your components will be hot when you do this. So give it a second before you remove the component or you will burn yourself. So just word of caution there. We all grab the component way too fast sometimes and it hurts. This is one, I have solder wick. I don't like using this. It's not as clean of a method. But what you do is you really put the solder wick between the solder iron and what you're trying to desolder, and you heat it up and the solder sticks better to the wick than the component, and then you pull the solder wick up and all the solder sticks to it and we've desoldered. I'll show you that one in class as well, or you can also see it on the video. Please note though, the soldering iron in picture 2 here, it's a tinned tip, so make sure you guys stick to that. Most important part, I know we've all passed the safety quiz by now, but this is something I will fire you if you are not wearing safety glasses when you are soldering or working on anything in here. Okay? Even if you're not soldering and the person next to you is, you need to have safety glasses on, because if they are clipping wires or things like that, okay, you have only one pair of eyes and you will not get them back. I expect you guys to be wearing your safety glasses. You will have them in a box that you will keep with you stored in the classroom, but you'll have that. Solder irons do not ever get set down on the desk. They will all be placed in a solder holder that we have, and you will always make sure that works well and will sit correctly and it doesn't fall apart before you plug in your solder iron. There is no on-off to the solder irons. It's literally, if they're plugged in, they're on. If they're unplugged, they're off, and it takes them a little while to cool. So make sure when you set these up, you give yourself plenty of space. You don't sit right next to someone. Make sure that your cord does not get wrapped up in your holder, okay, and that sort of thing. We got to make sure we have plenty of ventilation in our classroom. We have plenty of ventilation. Don't ever do this in a nice closed room or things like that. Make sure everything we're working with is safe, and make sure we have all of our components before we start soldering. So not only your board, your resistors, your LEDs, all those sort of things. Make sure we have the solder stand set up before we plug in the soldering iron. Make sure our sponge is wet. Alright, so when we sit down, we're good to go. And I'm going to be the one giving you solder, so let me know when you run out of solder. Keep your excess solder in your box and that sort of thing. Okay. Make sure, I can't emphasize this enough, space. You guys do not need to be on top of each other when we're soldering. It's not social hour. We will be able to do, we'll talk about it kind of as we go, you and I one-on-one, or maybe at the class at the end. But this soldering is something you really got to focus on, and make sure that when you're putting your solder iron back in its holster and things like that, that you're not hitting someone else's stuff or project as well. Okay? Please, please, please make sure we're not melting cords or doing those sort of things. I understand that it happens. Okay? You're not in trouble, but what you need to do is make sure that you tell me, hey, I accidentally burned this cord. It's more for safety. It's not, like, the solder irons are not expensive. They're like $10 each. I don't care about that. It's if you accidentally burn a cord, then we have a safety issue for everyone. It'll start a fire, all kinds of different things. It's okay if you screwed something up. You need to make sure that you tell me, and I will get you a new one, and we do what's necessary with the old one, whether we got to throw it away or do that sort of thing. Okay? Please remember, the solder irons heat this stuff up to 700 Fahrenheit. The molten solder, that's when it's liquefied, is extremely hot. And then it takes it a few seconds to cool off. So please, 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 please be very careful with that. So knowing that it's hot, I'm going to give you solder, but make sure that your strand of solder is long enough that your hand is a safe distance from the heat. So when you heat up solder, the whole strand doesn't heat up. It's going to heat up very local to the tip of the wire. But don't get your hands super close. I don't want your fingers 1 inch away from where you're soldering. It will be hot. You will burn yourself. You should keep 5 or 6 inches between you and the solder iron using your solder when you do this for safety. Alright? These are our basic safety guidelines that we have. You guys all took and passed the safety test anyways, but we just got to review. I'm very strict on this stuff. Tie back your long hair, because nobody wants to smell burnt hair or things like that. We will lean forward and get in the way if you don't. So if you do have long hair, you will have to have your hair bands to pull everything back. If not, I will supply you with a rubber band. Probably not the choice that you want to put your hair back. Alright, I don't want you having loose clothing, loose sleeves especially, those sort of things. Okay? Don't flick solder. Be careful. We got to make sure that you cut everything evenly. Okay, using those angle cutters, get as close to the board as you can. That way everything's nice, flush, and even. Please make sure that you pick up all of your scraps. Before we leave every day, your tables will be spotless, and all of your scraps will be in the trash can and not on the floor. Alright? Let's see, make sure leads don't cross each other, so make sure you clip them. You don't want two ends of a resistor touching each other because that aren't supposed to be, because now you've just shortened them and they aren't going to work. And like I said earlier, wash your hands when we are done. Everybody will wash their hands. We have multiple sinks in the classroom, plenty of soap. Wash your hands. Alright, lastly, there's a couple links here, so you need to make sure that you pull up these slides off my website, the lecture slides, and click on these links. I want you to watch them before we come to class so that you have an idea of how to solder. One actually goes through desoldering and stuff like that as well. Alright, then I'm going to demonstrate in class, and then you guys are going to solder your own boards. Alright, there's 2 or 3, maybe 4 projects that we're going to do soldering. One's very important. It's our breadboard companion. It'll be our power supply that we will use for all of our breadboarding. That is not the first one that you get to do, though. That'll be one of the last ones, because that one has to be done right because of how much we use it throughout the semester. So make sure that once you're done with the lecture, you take the lecture quiz at the end.